Okay, so the key idea then behind this task is that you give pupils hopefully an interesting problem, but crucially one that they can't solve without being forced to think efficiently and nudging them towards the nth term of a sequence. Now, although I didn't use any algebraic notation whatsoever, we still used the idea of the nth term sequence because I was doing this with a new Year 7 class in September. So the first thing that we did is we got out the algebra tiles. Now, the algebra tiles have a little bit of an advantage here because they're double-sided, and you'll see what I mean by that. And they built the first section of fence, and they all agreed that, yes, to make the first section you need four planks of wood. And then you ask the question, how many for the second section? And a lot of them, without thinking, might say 8 here. But then when you actually physically build it with the algebra tiles, and using the reverse side so you can see the difference, you can see that you physically have to add on 3 more panels to make the next section. And then the section after that, and every subsequent section, you're going to need 3 more planks each time. And I think it highlights a nice difference between the first term, or the first section of fence, and then every subsequent term in this sequence. Now, this was enough for a lot of pupils to realise how we're going to work out 100 sections of fence now then. So the first section requires 4 planks, and then we need another 99 sections of fence, and each of those sections of fence will require 3 planks. So this calculation here will give us the total number of planks for 100 sections, which turns out to be 301. Then we looked at it a slightly different way. Just move these out of the way for a second. And we wrote down the linear sequence that this pattern generated. So we started with 4 planks, and then every section after that required 3 more planks. So we used the terminology here. The term-to-term rule is +3. We generated this linear sequence, the first few terms of it. And then I said to these Year 7s, okay, can you think back to primary school? And when your teacher was teaching you how to skip count maybe in 3s, what did we call that? And they all chanted, oh, it's the 3 times table. So can you tell me the 3 times table then? And there was like 3, 6, 9, 12, and so on. And at this point, I just paused and I said, okay, this is our fence sequence, and this is the 3 times table. What do you notice? And it didn't take long for all the hands to shoot up. Sir, I've noticed that either this sequence is 1 more than this one, or this one is 1 more than this one. 1 less than this one. So, okay, that's brilliant then, but I want 100 sections of fence, remember. What is the 100th number in the 3 times table? Well, that's going to be 300, sir. And then without any other prompt in here, loads of hands suddenly shot up, and they all wanted to tell me what number must go here. Oh, sir, it's 1 more than the 3 times table, or something like that, which is exactly what I want them to say. So 301 here. And then we formalised that into an actual calculation. So what is it? Well, it's the 3 times table up to the 100th term. So 3 multiplied by 100. And then we need to add on 1 extra plank. And then we agreed that this calculation here and this calculation here give exactly the same answer of 301 planks. So it's a really lovely task to do with Year 7, and you can see we've got this idea of the nth term coming down here, but without any sort of algebraic notation yet. That will obviously come later. So hopefully you enjoyed that, and then as always, thoughts and comments in the thread below.